Thank you for the introduction. Yeah, thank you for the introduction. So again, my name is Brian Mock. I'm from Stanford University, and this work was conducted with my co-authors, Mishel Johns, Stephen Yang, and also with my advisor, Wendy. So today I'll be talking about transitions of control in partially autonomous vehicles and how transforming steering wheel systems could assist drivers in those situations. So in the realm of autonomous vehicles, there are classification paradigms such as SAE's levels of automation, which categorize vehicles by what responsibilities are allocated to the driver and to the automation. So vehicles of level 2 partial automation and level 3 conditional automation, drivers are still expected to take back control of the vehicle in certain scenarios. So transitions of control from automation are an important safety critical aspect that need to be studied. In our prior work, we looked at examining how much time drivers need for transition, particularly how they would perform when given a certain amount of time. We did this research utilizing a full car driving simulator where we could reliably test driving scenarios that may be too hazardous for an on-road experiment. And so next, here's an example of what our prior work looked like. So here the vehicle provides the driver with an audio alert and a visual alert on the instrument cluster.
Automation off.
However, sometimes these two things are not enough to help drivers during a transition. So as you can see, drivers may occasionally hesitate or respond slowly in a transition of control situation. After we conducted this study, we were interested in seeing if we could introduce a design intervention that could help improve the driver performance after transition. From the observations of how the drivers behaved in that study, we believe that it would be helpful to them if we could provide maybe better alert mechanism and also a clear indicator of which entity was in control. To accomplish this, we decided to design and test two transforming steering wheel systems. The first was a mechanically transforming steering wheel that utilized movement, something that people are very sensitive to. And the other was a purely visually transforming steering wheel. So for the mechanically transforming steering wheel, we started out with some initial foam core prototypes that we could evaluate and see what types of motion would be appropriate for a transition scenario. We had 3 design requirements for these prototypes that we believed, if satisfied, would help drivers. The first is that it needed to have distinct physical states. So with shape-changing interfaces, they have the ability to provide dynamic affordances. So by having 2 distinctly different physical states, it can act as a better indicator of who is in control and show when the driver actually has agency in controlling the car. The second is that it needs to have noticeable movement when transforming so that it could easily get the attention of the driver and alert them of the transition. For example, when we were evaluating these prototypes, prototype B had a more noticeable complex sweeping motion than prototype A, so it was favored for this requirement. And finally, you need to indicate that a transition was happening. And what we mean by that is when we're evaluating prototype C, for example, it looked like a handoff where the car was giving control back to the driver, compared to, say, prototype D, which a lot of our evaluators found as kind of foreign and as having its own agenda, unrelated to transition. So for the final prototype of the mechanically transforming steering wheel, we combined the 2 prototypes that we liked the most during our initial prototyping sessions. And in this design, the upper components of the steering wheel utilize the 4-bar linkage movement that you saw in prototype B on the previous slide, while the bottom utilizes the rotating element in prototype C that you saw. And when fully deployed, the steering wheel components dock together. And we believe that by having two different types of movement along two planes of motion would make the transformation even more noticeable. When we evaluated and developed prototypes for the visually transforming steering wheel, we similarly had 3 design requirements, and again, it needed to have distinct visual states, it needed to be visually noticeable, and it had to indicate transition of control. So we tested out a few different prototypes, including a display attached to the center of the steering wheel, projections onto the steering wheel, and LEDs embedded along the circumference of the steering wheel. With the display prototype, we found that it had a constrained viewing area, so sometimes it was not as effective in getting the attention of a driver. The projection had a different problem in that information can occasionally be obscured by the driver. So because of that, the LED prototype, which didn't have some of these drawbacks, was selected for the final design of the visually transforming steering wheel. Here's a basic system diagram of these steering wheels. So they were designed to be interfaced with our full car driving simulator. And the driving simulator would be able to send commands to a Raspberry Pi via UDP, and then the Raspberry Pi would relay those commands to a Arduino on each of these steering wheels, which controls the behavior of each individual steering wheel. So next, we conducted a quantitative driving performance study to see if these steering wheels actually had an effect on post-transition performance. To be able to compare these results with the results of our previous work, where participants were using a standard circular steering wheel, we utilized the same course design and event design. Participants in this experiment were not given any secondary tasks, so when the automation was enabled, all that they could do was monitor the car. We had a 2x2 design where one factor was the transition time and the other was the steering wheel. For the mechanically transforming steering wheel, we had 28 participants, and also for the visually transforming steering wheel, we also had 28 participants. The participants' age distribution had a mean of 29.3 years with a standard deviation of 11.1 years. So this is the course that we use. Control of the vehicle alternated between the driver and the automation, as you can see. At the beginning, the driver goes through a 5-minute practice section so that they can become acclimated to the driving simulator. After 5 minutes, they're asked to enable the automation. So after driving for 10 minutes along a very straight, uniform section of road, the car encounters a road hazard in the form of a curved section of road that is lacking lane markings. Participants experience a unstructured transition of control where they're immediately given back control 2 or 5 seconds before the car enters the curve. 2 sets of pylons bound the area that the car should stay in, with 1 set of pylons closing off the right lane and another set indicating where the center divider would be. Oncoming traffic to the left and an excavator on the right discourage participants from leaving this area. And so here's the example of how the steering wheel behaves during transition. So for the mechanically transforming steering wheel, when the automation is on, the steering wheel retracts back in to indicate that the car is in control, the automation is in control, and the driver no longer has as much agency. When the automation is off, the steering wheel deploys outward to indicate that the driver needs to take back control. And so here's an example of what that would look like.
Please enable automation.
So the participant presses a button and the steering wheel folds back in. When they get to the vent, the steering wheel pops back out.
Emergency automation off.
Oh my God.
As for the visually transforming steering wheel, it had similar behavior where when the automation was on, it would glow green to mirror what was on the instrument cluster. When the automation is off, it would become unlit. So that the visually transforming steering wheel would be able to mimic the mechanically transforming steering wheel during the transition back to the driver. The steering wheel would glow red for the same amount of time it took the mechanical transforming steering wheel to transform. So this is what the
Please enable automation.
transitions look like.
Emergency automation off.
Oh my god. Shit. Jesus.
All right, so onto our performance metrics. We had a couple. The first was road excursions. So we had a classification where if the participant did not hit any of the pylons, it was considered no excursion. If part of the car hits a pylon, it was considered a regular excursion. And if the entire car was on the other side of the pylons, it would be a catastrophic excursion. And these were the results for the two steering wheel systems and also for our prior work. So when we conducted Fisher's exact tests, we found that for the total number of excursions, there wasn't a significant difference between the conditions. However, if you do look at the catastrophic excursions, you'll see that the mechanically transforming steering wheel doesn't have any. So it actually did significantly better for that measure. And when we reviewed some of the video, we found that most of, all of those excursions were small grazes against pylons versus going out into the grass or hitting a car. So another measure that we used was the standard deviation of road offset, which indicates how far the car is away from the center of the lane. So this metric looks at how stably the participant negotiated the event. And we see that the mechanically transforming steering wheel performed significantly better than the visually transforming steering wheel and also our standard steering wheel case. Another measure is the standard deviation of steering wheel position. And again, this looks at how stably people negotiated the event. And we found that, again, the mechanically transforming steering wheel was better than the visually transforming steering wheel. But there weren't any significant differences between both steering wheels and the original prior work case with the standard steering wheel. So we have some implications for design from these results. We saw that the mechanically transforming steering wheel was better than for certain metrics. So we believe that this type of system should be considered for the development of autonomous vehicles. We also found that the visually transforming steering wheel, although it didn't do very well, was not significantly worse than the standard steering wheel. And one of those implications is that both steering wheels could be potentially used for other other applications that are not related to transition of control without any significant detrimental effects. So I'll just quickly go over a few of those other applications. So one of them is, that the visually transforming steering wheel could do is to help with indicating the vehicle's intention. So as you can see there, since the visually transforming steering wheel is decoupled from the actual steering wheel, it can show what the car is about to do before it does it, which could potentially help increase trust. Another application that we thought of is with the
That's so
mechanically
cute.
transforming steering wheel,
It's like a little baby.
where it could
Or
potentially
a
act as a
chicken with
interactive
legs.
robotic avatar.
Okay.
Maybe like tell me how you feel about these.
That, it's like a little foot coming out to kick you. That would, for some reason that feels okay if it's just one of the little legs.
Mhm.
Like it's trying to get my attention on this side, or it's trying to wake me up, or... Like, the steering wheel has a lot more fun on my drives than I do.
So we actually did a small exploratory study with a few interaction design experts looking at different types of animations, and we found like a few common threads with our experts viewing that directional animations help them be alerted towards something in that direction, and so just a summary again of the contributions from this paper. So we designed and fabricated 2 transforming steering wheel systems. We tested them for their effectiveness in helping drivers perform better after a transition of control. And we also introduced some potential applications of these 2 steering wheels outside of the realm of transition of control. All right. So I'm happy to take any questions. We have a demo after this session at 6 o'clock if you want to see this mechanically transforming steering wheel.
Hello, I am Daniela Brieto Falsino from Carleton University. I have a question related to the 2 different steering wheels. I wonder what is the influence of the sound, the noise of the mechanical steering wheels when it's transforming, and also its own shape in terms of the results you got
The form
from
factor?
the usability
Yeah,
test.
so the sound was definitely something that we had not intended for. And actually in our little follow-up exploratory study, a lot of our experts mentioned that the sound could have been a potential factor in helping increase performance. So that's actually one of the next steps would be kind of looking at designing this without that sound, or testing it without the sound component to see if people are still very sensitive to that motion. As for form factor, why it is not the conventional circular steering wheel, in the initial prototyping process, we found that a lot of the kind of circular steering wheel concepts, it still implied that there was like a lot of agency, that people could grab it and take control. So we tried to avoid the circular prototypes. In a paper that we actually had published, we kind of look at the form factor of this steering wheel, and we found that it did not really have a significant effect. So we tested this where it remained deployed all the time. So it would never retract back in when automation was enabled, and that didn't have any significant increases in performance. So although the form factor is actually kind of foreign to people, it didn't factor into the increase in performance.
Okay, thank you.
Great. Thanks a lot.